So my name is Ben Corrie. I've been with VMware for about 5 years now. I'm a senior staff engineer here working on a project called Bonneville. So Bonneville is a project designed to look at how we most efficiently and effectively provision containers directly to the hypervisor, bypassing the need to have any kind of container host running within the hypervisor as a prerequisite. So in the Docker case, effectively what we've done is we've made ESX and vSphere the container host, right? There's no need for a Linux container host. So when we're provisioning containers, they run alongside VMs as first-class citizens on the hypervisor. They release resources back to the global pool when they're shut down. They're basically exactly the same as VMs. So about 18 months ago, I was working on a big data project here at VMware where we really needed to spin up large amounts of VMs very quickly. And Docker really appeared on the horizon. It seemed like a potentially interesting way to optimize that. And at the same time, I was really interested in the potential of a cloning technology we have at VMware called Instant Clone. And the light bulb moment for me was when I thought about how we could combine Docker and the instant cloning to give ourselves a container provisioning mechanism that operates directly on the hypervisor. In the last couple of years, the whole notion of containerizing applications and the container ecosystem has really come of age. There are so many companies bringing new things to the marketplace. People are very excited about the idea of building applications into containers. Containers, though, as we know them today, their most fundamental are software paradigms. They're sort of software virtualization. So when we want to create a container inside of an operating system, it's simply a matter of creating a namespace or creating some degree of isolation, some little space that application can run inside of that operating system. There is definitely, though, a place for hardware virtualization in this container story. The whole notion of a container in the abstract is a namespace, private namespace, and some resource constraints, right? A VM is exactly that, right? It's a private namespace with some resource constraints, but it is virtualized at a different layer. It's virtualized at the hardware layer. We can do any operating system that we like, right? That's a big one. And actually recently, as part of a hackathon at VMware, we actually did a full MS-DOS Docker implementation that demonstrated that really effectively. And the reason we chose MS-DOS was because we wanted to take one of the most legacy operating systems that would never even have been designed for containers, or no one would even think about combining the two. But by using the abstractions that we have in the hypervisor, we're actually able to get all of the pieces in place. The layered file system, the networking, the storage, all of those pieces applied to an operating system that is completely outside of Linux. Being able to provision containers with hardware virtualized levels of isolation and security is a big deal, because when we virtualize containers inside of the same kernel, inside the same operating system, there is an acknowledgement that you don't get the same degrees of isolation and security that you get with something like a VM. So if we think about the differing needs between the dev community and the ops community when it comes to how they work with containers, the dev community really need just the speed, fundamentally, of a container, right? They want to be able to just have a Linux host, spin containers up and down, commit images, continuous deployment. Ultimately, the containers are just the grease that allows them to get code out efficiently and quickly. If we think about the needs of the ops guys, they really need to think about the mechanics and the infrastructure of how these things are provisioned. There are considerations like, well, the container host, what operating system am I running? What kernel am I running? What patches should it have on it? How big should it be? These containers, should they be co-located with each other? Do they need to share data? Should I isolate containers from each other? There's all sorts of considerations that really have to go into that provisioning story. And I think that Bonneville really answers a lot of those questions, because by eliminating the container host entirely and giving you the convenience and the efficiency benefits of containers with this sort of enterprise back end of the hypervisor, really for the ops community, you're getting the best of both worlds there.